Hey everyone, my name is Venelin. I'm responsible for the development of the semantic publishing benchmark. I will talk about the evolution of this benchmark. We have been working on it for the past 2.5 years. You can see in the outline there are several points that we have been working on. I want to let Naso, the CEO of Ontotext, say a few words about the motivation to evolve to version 2.0 of the benchmark, and then I will continue with the technical stuff.
Hello. So just a few words because the slot is not very big anyway, and we did plenty of changes in SPB that we really have to talk about. So SPB is mostly the use case is such that Sparko and RDF should add value by allowing publishers to retrieve relevant content using reference data, rich metadata, descriptions of content, and these kind of things. So that's the one promise, and then the second promise is make this easier from developer's point of view and from query definition point of view, if you want. And when we looked, probably half a year ago, critically again at the first version of SPB, we figured out that there are things that we can make better in both respects, and that's what we are doing. So at the end of the day, we've been trying to achieve more pertinent use case for triple stores and to make it also more challenging, because at some point we felt like it's for a new benchmark it's not challenging enough for GraphDB and for v2.0. These were the two engines that we had some experience with this benchmark. So the major things are there is something we call the reference knowledge. So these are all the taxonomies and data sets, like lists of entities, concepts, whatever people are using to describe content, whatever the publishers and the media are using to describe their content. And this reference data set that we used in the first version was rather small, and it wasn't properly interconnected. So there were plenty of interesting things that you weren't able to demonstrate just with the initial set of reference data. The other thing was that it was too small. So it was in the range of probably 200,000 statements. That's by today's standards, and what we see in real applications in publishing is really small. So we want to get this one bigger and to enable better and more interesting use cases when it comes to these publishing workloads. So these are probably the major things. So we needed a bigger and better interconnected reference knowledge to make the geography of the data set that we can generate more interesting and more challenging. We want to demonstrate how inference can help make better and easier queries, and can add value, because that's one of the promises of triple stores anyway. And there was plenty of space for making more challenging queries, like given we have a better reference data with more interconnections between the different entities, this allows one to make queries that are like, give me content about entities that are related to something, which was not that easy with SPB 1.0. If we're speaking about the directions in which we want to go, we also wanted to add to this benchmark some high availability features like online backup and other things. In practice, we weren't able to do this in this version of the benchmark, but we'll keep working on this in the future. So one of the inspirations of the next of SPB 2.0 was the pattern that the very same guy, actually, James Rayfield, who was with BBC, now he's with FT, the way in which he evolves his vision about dynamic semantic publishing. And that's evolving quite substantially. In this version of the benchmark, we weren't able to really... Okay, we got some like sample data sets, sample queries, sample query logs from Financial Times, and actually Jem was supposed to attend this meeting and to present their usage. but his wife is expecting a child in literally a week, so he was finally not allowed to leave home. So we were able to look at this, everything that they have in their current scenario 4 years later, but the time constraints were such that we weren't able to adopt this. So we got some requirements, and we get informed by this use case, but that's currently not really part of this version of the benchmark. So that's everything from me. I'm giving the floor to Venelin.
Thank you, Naso. So we'll continue with the new reference data sets. As you can see, at the moment, the new reference data sets are they consist of 22 million explicit statements versus 127,000 statements in SPB 1.0. We have added reference data from DBpedia, DBpedia companies, events, and persons. We have also enlarged the dataset for geonames. We have included all European countries with some exclusions, which totals in about 650,000 locations. Also, we have stripped some properties from the geonames dataset, which are not relevant to the SPB. We have also added same-as links between DBpedia locations and geonames, which makes things more interesting in terms of the queries. In this slide, you can see some statistics about the entities from the reference datasets. Now we have substantial volume of connections between the entities. Geonames, for example, come with hierarchical relationships with the parent feature. DBpedia inter-entity relationships are, as you can see, companies to person, for example, 26,000, or to places. All of these entity-to-entity relationships in the reference data was not present in the previous version of the benchmark. We are using GraphDB's RDF rank feature to calculate a rank for all the entities from the reference data. We have decided to use this because this would make the query workload much more interesting. How we do this? We first load the data in the database in GraphDB. We then calculate the ranks, and then we store those ranks as data. So it actually doesn't, we don't need to calculate it anymore, we have it there. And when the data generator starts to generate the synthetic data, it defines a set of popular entities. For example, in the previous version, we used a random generator to pick those popular entities. But at this moment, we are using the RDF rank of the entities, so that the first 5% of the entities are selected as popular, and thus, when they are tagged in the metadata or the so-called creative works, then the queries the chance of the queries to hit more interconnected data is much bigger. So next thing is the changes in the generated metadata. We have evolved our notion that the metadata which tags relevant entities from reference data now needs more descriptions to have. For example, from the previous BBC dataset, we extracted some statistics, and those statistics showed that there are about on average 3 entities which are referenced in the metadata. But at the moment we we think and we are certain that that numbers have increased. So we have decided to triple the number of entities which are tagged by the metadata. We have decided to keep the distribution, however, extracted from BBC because it is a real life distribution. Only we have tripled the number of taggings to the reference data, which results into average 8 content to concept references and increase of the statements per creative work or per metadata unit to 25. In the previous version it was about 19 statements. And everything else, all the heuristics and specifics of the metadata generator were preserved. Geonames URI to location references. As in SPB version 1.0, we have one of the properties, which is a mention property. It is like reserved for geonames location. Each creative work is tagged with some location. Most of the geospatial information actually in the data generator is not most, but all the data generated by the data generator is using the geonames locations. And as you remember, we have added the same as relations to DBPD locations, and things become interesting because in the queries, the substitution parameters we are using, they are not actually geonames locations, but they are DBPD locations. So the correct inferencing will produce correct results only if the same as mappings are inferred correctly by database engine. As you can see in this table, this is the change in the reference dataset and the generated data. There are some statistics here. We have increased the reference data from 170,000 statements to 22 million. And the average number of explicit statements per creative work or a metadata unit from 19 to 25. The size of the metadata, actually, we decided to lower the size. For example, when we want to generate 50 million data set, because we have now 22 million reference data, we will generate 28 million metadata and not 50 million as it was before. But still the numbers, the total is the same. As you can see at the bottom, we have creative works to entity relationships for 1 billion, which are increasing from, I think, more than 2 times. We continue with ontologies and rule sets. For SPB 2.0, we have added in SPB 1 version 1, we just used the RDFS subproperty of and subclass of properties. We have added 3 more in the second version. It is transitive property, symmetric, and same as. Each triple store which is supporting the L2RL reasoning should be able to process the SPB 2.0 correctly, but actually it doesn't need to support all this. The full rule set. Actually, we are using a much more simplified rule set, which suits the needs of the SPB 2.0. We have done some slight modifications in the BBC ontologies. As in version 1, we have a core ontology which defines the relationships between persons, organizations, locations, and events. In order to integrate the DBPD and geonames classes and relationships, we have just added a few more of those relationships in the core ontology, which suit the needs. We have also added the parent company property, which is a transitive property. Also, we have modified the geonames ontology. We have stripped out on property restrictions, which are imposing cardinality constraints on the data sets, and we think are not relevant to the results produced by the benchmark. We continue with the inference patterns. For the geonames dataset, we have the parent feature property, which actually is a transitive property. As an example, if we take a Munich, which has a parent feature of Bavaria, and then on its turn Bavaria it has a parent feature of Germany, the proper reasoning should infer that Germany is also a parent feature of Munich. This thing is noticeable in the queries, so if the RDF engine is not performing well in reasoning, we'll get no results for those queries. We have also the same transitive closure on the DBP ontology, the parent company. Again, we have company control relationships. We have a parent company, child company. I mean, it's more or less the same as the geonames. Same as relationships between geonames and DBP locations. I think I mentioned that earlier. We are actually defining a link between each geoname location, or most of the geonames locations, and the DBPD locations, so that when we ask a query with using one of the DBPD locations, it should produce a result, but the result is containing geonames locations. We have kept the patterns from SPB 1.0 related to the subproperty of and subclass of properties. Actually, we had decided to use in most of the queries the super property, the CWork TUC property, which actually would produce some kind of inference, and again the result will stay the same, but it will be more challenging for the inferencing engine to cope with. Again, we have a creative work, which is a parent class of several types of creative works, but this has not changed because we are utilizing this in the first version of the benchmark. So this part of the inference patterns are staying more or less the same. Some statistics about the inference. If we try to use brute force materialization, the reference data will grow 5 times. If there is no same as expansion considered, or materialization on top of the reference data, we will add only 7 million statements which are coming from DBpedia datasets and the ontology, which, for example, will make life much easier for some of the triple store who support some kind of same as optimization. That's why we decided to add this. Again, a brute force materialization of generated metadata would double the number of statements as compared to the previous version. It was 1.6, which is not that much. We have added some changes to the basic interactive query mix. We have added 2 new queries. Most of the queries are actually staying the same. We have just modified the CWork about and mentions properties, which are which have a super property CWork TUC, and that way the results again should stay the same, but the inference engine will have to do a little more job to produce them, a little more work. As I mentioned, we have 2 new queries in the basic interactive query mix. We have Q10, which exploits the geonames metadata, geonames data. It retrieves creative works about, that mention locations in the same province. And then we have also added some time constraint of 5 days, which would limit the result in some way. We don't want to have the whole bunch of entities stacked for the whole period of the generated data interval. We have query 11, which retrieves the most recent creative works that are tagged with entities related to a specific popular entity. This query is interesting because it retrieves inbound and outbound relations, which can be explicit or inferred. This is a sample of query 10. The idea is to get some DBPD location, which in turn, using the parent feature of geonames, if you remember, as I mentioned, we have a mapping with same as, should produce a result of all locations in the province or the administrative area with code a.adm1. And then for each of these locations, we will produce some kind of result. Query 11, it exploits the, it retrieves inbound and outbound relations to entities from DBpedia. Again, it is interesting because it exploits the infer to explicit once statements in the store. We have about the validation. We are keeping the validation as it was in SPB 1.0. As I mentioned, some of the queries will not produce correct results. I mean, they will return no results if correct inferencing is not supported by the RDF engine. More or less, the validation will stay the same as it was until now. We have produced some sample results with GraphDB. We are using this configuration to run the second version of the SPB benchmark. We have a forward chaining reasoning using the RDFS optimized rule set with addition of the three AL2 properties we have added, inverse, symmetric, and transitive. We have enabled the same as optimization, which is beneficial because we don't get the full materialization of all the triples from the reference data and generated data. We have the geospatial index enabled, which is vital for query 6. And also we have a USIN connector index for full text search. Again, it helps a lot in query 8. We are using one of the latest versions of the standard edition of GraphDB. We've decided to test with the scale factor 1 of Semantic publishing benchmark, which is 50 million statements. The hardware, as you can see, it's a normal desktop machine actually, nothing special about it. We have configured the benchmark to execute 8 reading and 2 writing agents, and the runtime of the benchmark is 40 minutes. And as a result, we have achieved 13 updates per second and 44 selects. I'll say something about the future plans. We think that relationships between entities in reference data are not enough. We want to add relationships between the generated metadata. So it could be some kind of collections or storylines which will follow some chain of events, or for example, article or images related to it. We will extract the modeling content to entity cardinalities from the FT data, from the data sets provided by FT. We also will analyze the query frequencies which are executed live on the FT data set. So we plan to implement those features. We want to experiment with loading and updating of big data sets. This will be interesting for us. And last but not least, testing high availability is an important feature for each database, and we plan to implement it at some point in the next version. As a summary, we have a much bigger reference data set. It has grown from around 200,000 to 22 million entities. We have added much richer geonames dataset for Europe, and also we have added 40 million statements from DBpedia, companies, persons, and events. We have now interconnected reference data, more than 5 million links. We are utilizing inference now much more comprehensively than before. Again, we are not using the full potential or the full set of rules which are exist in the OWL dialect, but the most vital for such kind of benchmark. we have sample queries, which are the two new queries. Actually, they are operating more or less on the reference data, and they're utilizing the links in the reference data more and more efficiently. And we didn't have such queries before, and we think this will provide a much more relevant and real results to the benchmark. And retrieval of relevant content through links in the reference data. This feature is this is a part of each semantic publishing platform and didn't exist in version 1. So we think it should be present. So we have added it to version 2.0.